Let's try one more example of those two-dimensional force vector addition problems that we started looking at yesterday, spent a little bit of time on earlier today. This time, we're going to change it up a little bit. It's not a circle being pulled in 3 directions. It's a box, a square being pulled in a few different directions. Think you can handle that? Let's see what we can do. Okay, we got a force down here. We'll call this F1. It's 100 newtons. Let's say we got a force right here. Let's make this one also 100 newtons. We'll call this F2. And boy, we're really going to change this one up, Dom. 60 degrees. We're not going to put a third force in there. In the end, if you can solve it with 2 forces, you can solve it with 15 forces. It's just more work with 15 forces, that's all. Okay, your challenge here is to, or your task, I should say, is to find the net force acting on that object. The net force including direction. Okay, we'll give you a couple minutes now, and then we'll take a look at it. All right, let's have a look at this. This, when we glance at it, appears to be, again, a two-dimensional force vector addition problem. Now, we may get lucky. If we get lucky and find that 2 forces cancel each other out and we're left with forces on only one of the axes, either x or y, that's great. Then we can treat it like those old problems. F net is equal to the sum of the forces. But if we don't find that something cancels out, and I don't think we will here, then we've got to treat it like we did that last problem with the x and y components. In order to know whether forces are going to cancel out or not, what we're going to have to do is take a look at that funny angle and get rid of it. So off to the side over here, let's draw it out, 60 degrees. We got 100 newtons right here. We got an x component. We got a y component. We're going to say cosine 60 degrees is equal to adjacent over hypotenuse. Dom, lightning fast calculation here. What's it going to be? 50 newtons. Good. Sine 60 degrees is equal to the y component over the hypotenuse, which is the opposite side. And, of course, the y component ends up being equal to 86.6 newtons here. All right. Now we can, if we want, replace this with 50 newtons to the left and 86.6 newtons up. Just like we did way back when we did vector addition with displacement way back in Unit 1, back in September, end of September. Let's say x's and y's. The x component of the first one is 0. The y component is negative 100. The x component of the second one is negative 50. The y component is positive 86.6. Add these up, negative 50. We got negative 13.4. So let's say we got 50 this way, 13.4 this way. The net force is going to be the Pythagorean theorem. The angle is going to be the inverse tan function of opposite over adjacent. What does that force work out to be? I'm going to say 54, 55-ish, 52. And theta is the inverse tan function of opposite over adjacent. The inverse tan function of 13 over 50, that's going to be a pretty small angle. A little bit of a guess here, 20, 15. Oh, you're not going to believe this, but I was going to say 15. Don't believe me, do you? 15 degrees, and this would be south of west. Good. How many people got that? Okay, good. We're better. We're better than they were in the last one. You guys feel comfortable with that for a little quiz tomorrow? Yeah? I see most people saying, yeah. I saw a couple of people doing this. Hey, if you're doing this, if you're not comfortable with this for a quiz tomorrow, okay, pop in during scheduled help or lunchtime, and we can do something about it, okay? Here's the other question that's going to be on your quiz tomorrow. We did a couple like this yesterday as well, right? Here's your wagon. One of those wagon problems, remember? 30 degrees, our standby angle. The force is 100 newtons. Okay, we got a mass of the wagon of, let's say, 20 kilograms. Okay, we got a force of friction acting this way of, let's make it 20 newtons. Look, we got gravity acting down. We have a normal force acting up. Hey, why did I draw the normal force smaller than gravity? We talked about this at length yesterday, right? Yeah. Yeah, because I'm pulling the wagon at an upward angle, I'm helping the normal force. The normal force doesn't have to work quite as hard because I'm helping it along. Somebody in the last class said the y component of this applied force is an assist. Hockey playoffs start tomorrow, right? It's an assist. The y component is assisting the normal force, is helping the normal force counter gravity. Now, combined, this and this cancel out this, right? The downward force has to equal the upward force if it's not going up or down, if it's just moving horizontally. So these two upward forces combined have to balance the downward force of gravity. Yep. Yep. No. So like with the coefficient of friction, no. I might do that to you at some point, but I'm not going to do that to you in the quiz tomorrow. Okay. So don't put it in the back of your mind and say I'm not going to ever worry about that. But I want to test you on this first and see where you're at without the coefficient there first. Okay. So what do we got left? Well, we got two forces because all the y components cancel. We're going to say the net force is equal to the sum of the forces. That's FF plus Fx. But we got to get Fx, right? We can do that. X would end up being equal to that 86.6. So we're going to say 20 times A would be equal to negative 20 plus 86.6 newtons. 66.6. Uh-oh, that doesn't sound good. Sounds like a devilish question here. 66.6 divided by 20. 3.33. 3.3, right? 2 digits. Meters per second squared. Good. So basically, your quiz tomorrow is going to be this question with some different numbers, this question with some different numbers, maybe a third vector in there, maybe not. If I put a third vector in there, it doesn't make it harder, does it? Just a tiny bit more work. Okay, let's nail that quiz tomorrow, okay? If you're having a little bit of trouble with it, again, see me scheduled help tomorrow, lunchtime tomorrow, we can take care of that. Okay, I got one more question that will not be on the quiz tomorrow. Here we've got two objects, a 20 kilogram object, a 50 kilogram object. We're pulling this system, they're connected in the middle. We're pulling the system to the right with a force of 130 newtons. And we got friction acting on both of them, 10 newtons and 25 newtons. And the question is, what's the force of tension in the rope between them? Oh, that almost sounds like kind of from left field, like how far did the ball go when it was released from the elevator that was traveling up over the pulley on the inclined plane? That real tough question, challenge question that we had before spring break. It's not that bad. Trust me, it's not even close to that bad. It just kind of seems kind of from left field right now. Once you see it done, it's not going to be so bad. Okay, here's what you got to do. First, I want you to think back to an analogy that I gave you earlier. Remember the ice cream truck? The semi-truck that carries the ice cream in the back? Remember that one? We got a big box of ice cream in this truck, a 20 kilogram box of ice cream, and then we got another big box of ice cream, 50 kilograms. Surrounding that big box, those big boxes of ice cream, is a truck. Typically, you don't analyze the force of one ice cream box pushing on another ice cream box. Typically, you analyze the truck with all the ice cream inside it, right? That's what we're going to do first. Analyze the whole thing as if it's one object first. And that's pretty easy, actually. All we're going to do there to analyze the whole system, the entire truck, if you want to think of it as the ice cream truck again, is say F net is equal to the sum of the forces. FF1, the force of friction on number 1, plus FF2, plus the applied force, the force that we're pulling it to the right with. Now, what mass do you think you'd use for the net force there? This step is probably the trickiest step, actually. I'm sorry? The combined mass, yeah. So 70 kilograms times the acceleration equals negative 10 plus negative 25 plus 130. Negative 35, 95, 95 divided by 70 is what? 1.35, keep going. Okay, that's good enough. 4 or 5 decimal places is good enough. The reason we don't want to round that to 2 digits is because this isn't a final answer yet, right? So we found the acceleration of the system. If I had drawn a picture on the board like this, okay, here's a 70 kilogram object, here's a force to the right of 130, here's a force to the left of 35, you would have analyzed that and solved for the acceleration, no problem. You would have gotten the exact same answer we just got. We just analyzed the system. Easy, kind of. But now to find the tension in between, we have to do something else. It's not crazy hard, but a little bit different. We have to analyze one object. Now, you can pick whichever one you want, the 20 or the 50. Typically, we pick one on the end of the system. If there happens to be 4 or 5 or 6 objects on the system, we pick one on the end, either the first one or the last one. But here, there's only 2, so it doesn't really matter which one you pick. I'm going to pick the 20. If I do that, it means I've got a force of friction acting to the left on the 20. We call that FF1, and it was 10 newtons. And I got a force acting to the right. That's the force of tension in the rope that joins them. That's it. There's gravity and normal force, but they cancel. So acting directly on the 20. This ice cream box within the truck has friction acting on it, and another force that acts between the 2 ice cream boxes, the rope that's joining these 2 together here. Let's say F net is equal to the sum of the forces, FF1 plus FT. Remember, we're analyzing one object only now. What mass am I going to use? How do I get rid? Anyone for the mass? Yep. Yeah, just the 20. I've told you to use the mass of the whole system, but if we're analyzing just the 20, that is the system now, right? The smaller internal system. 20 times A, we know what A is, 1.3571. If the whole thing accelerates at that rate, then each individual object does as well. FF1 was negative 10, FT is whatever. Do the math there, we end up getting 37 newtons. 37 newtons rounded to 2 digits there. All right? Hey, what would have happened? What would have happened if I had have analyzed the other object? We got another object up here, it's 50 kilograms. Drawn the free body diagram for that. What do you think I would have gotten for FT? Almost. Negative. If object A applies a force on B, object B applies an equal and opposite force on object A. So it doesn't matter which one you pick. Hey, I did this one, get positive 37. You do the other one on the quiz tomorrow, get negative 37. It doesn't matter. They're both right. Right? We'll leave it there for tonight, guys.